Good morning, everyone. If you are just joining us, welcome to the Rising Stars in Data Science workshop. This is a workshop that is hosted by the Center for Data and Computing at the University of Chicago. I'm Julia Lane. I'm the executive director of the center. For everyone on Zoom, welcome back. We are going to continue the workshop with a very exciting panel that it's going to focus on a very broad and ambitious topic, the future of data science. And I'd like to get us as much time as possible with this panel, so I am going to hand this off to the moderator, David Uminsky, who will begin the questions and introductions of the panelists.
Thanks, Julia. It's very exciting to join and be able to moderate such a distinguished panel. As Julia said, I'm Dave Uminsky. Thinking of futures of data science, I just joined the University of Chicago because I was strongly recruited under the vision that UChicago has about the future of data science here, and I'm really excited that this is going to be the topic for today's discussion. My first panelist I'd like to introduce is Dr. Kate Baker, who's the Dean and Emmett Dedman Professor at the Harris School of Public Policy. Dr. Baker is a renowned researcher on the effectiveness of public and private health insurance and its impact on society as a whole. She's an elected member of the National Academy of Medicine, member of the Council of Foreign Relations, and a member of the American Academy of Arts and Sciences, just to name a few of her prestigious appointments. Before joining the University of Chicago in 2017, she's the Boyden Gray Professor of Health Economics at Harvard. Welcome, Dr. Baker. I'm excited to have you join us. Our second panelist is Dr. Mike Franklin, who's the Liu Family Chairman of Computer Science, also the chair of the Computer Science Department and senior advisor to the Provost for Computing and Data Science. Mike is a database, data management, and all things data expert. Before joining University of Chicago in 2016, he held the position of Siebel Professor of Computer Science in the EE at Berkeley, where he co-founded the famous AMP Lab, which among many of its accomplishments created and launched Apache Spark. That was very exciting to me when I first was in contact with him. I'm just as delighted, though, to introduce Dr. Dan Nicolai, who's a professor and chair of Department of Statistics in the college, also has an appointment in human genetics and medicine. Dan's major area of research are in statistical genetics and mathematical statistics. As a mathematician, I have great appreciation for this area of work. Dan's main area of focus are motivated by applications in genetics and genomic studies, particularly on common and complex diseases. I should say, in partnership with Mike, Dan is the co-founding faculty director of the data science initiatives here at the University of Chicago, and half of the recruitment team that convinced me to come over to the University of Chicago. Last but not least is Dr. Karen Levesque, associate professor at Toyota Technology Institute at Chicago, and also holds an academic appointment in computer science at the University of Chicago. Karen completed her PhD at MIT in electrical engineering and computer science before joining TTIC in 2008. Her work in natural language processing is truly outstanding and has received numerous awards. I'd note just the most recent one where she's recently been awarded the IEEE Signal Processing Society Distinguished Lecture for 2021 and 2022. That was a very hard set of lists of accolades I had to cut down to keep this short. I'm very, very delighted at everyone who can join us here. And I think we should kick this right off with a couple sets of opening questions, and I think our panelists are well prepared. But I do want to just pause here for a moment and address the rising stars that are here in the room, and really the focus of today's whole workshop is keep the questions coming. We will have time at the end for some dedicated Q&A, but throughout the entire panel, I'd love, to be able to interrupt and inject questions as you guys see fit. This is really for you to get a sense of the incredible people and things going on here, as well as the wider audience that's joined us today. So, and I do want to extend that invitation as well to those joining us through YouTube. Questions there will also be able to make it into this session as well. All right, so let's just start this off. And this is a question for the whole panel. So this is the future of data science, and really this is also U Chicago. So I want you to put those two things together, and from your perspective, your department, the things you're working on, what is the future of data science at U Chicago? How is this the place that's engaging in this cutting edge interdisciplinary data science research and education? What's really going on here? And maybe to start us off, how about we have, I'm flipping a coin in my head. How about Mike? Can you start with that?
Sure. So first of all, thanks everyone for attending the workshop and for the organizers for putting it together. Just to say it quickly, it's hard to think of a better topic for U Chicago to really excel at and to pioneer, as well as it's hard to think of a better place than U Chicago to really build out the foundations of a new field of data science. And, the reasons for that are pretty simple. First of all, the University of Chicago is a place that has a long history of defining fields and areas of intellectual activity. It is a place that views itself as breaking traditional research boundaries and research silos. And, it's a place where people genuinely appreciate and engage in, interdisciplinary work. And, data science by its very nature is going to require an interdisciplinary effort. It involves people from the methodology areas of, computing and statistics and applied math, and psychology and so on. And it involves people from the domains that are the places where data is being produced and consumed and put to use. So to me, it seems like a natural fit for an ambitious effort to define a new field of data science. And I think that's what all the people on this panel and really across the university that are involved in data science have signed up to do.
Fantastic. And maybe, Kate, could you talk a little bit too from your perspective here at Harris?
Sure. And I can answer from the perspective of somebody who's not trained as a data scientist per se. One of the things that's most exciting to me about what we're doing here at the university is the marriage of those cutting edge data science tools that you and colleagues have gone so far in advancing with the deep understanding of how those tools play out in real world markets, policy choices, the analytics that have to get dovetailed with the data tools. We all know that when you have giant data sets, you can find all sorts of statistically significant patterns that are not actually meaningful levers to pull in changing how things work in the world. You need to have that sophisticated data analytics combined with an understanding of cause and effect, with an understanding of how changing the real world environment is likely to cause a change in the outcomes you really care about. So as a person who's really interested in policy in general and health policy in particular, I'm excited about the potential for machine learning and artificial intelligence, not just to help us better identify the patients with, this particular type of tumor, which is wonderful. Like, we need to be applying the tools around the edges of medicine that way, but we can also move the way healthcare is delivered by drawing out signals that let us design health insurance plans better, that let us change healthcare markets. That's just one example, but I think that it's a really powerful combination and one that the University of Chicago is particularly well situated to take advantage of and really advance.
Thanks, Kate. And Karen, from your position at TTIC and the work you're doing over there, we'd love to hear about your thoughts.
Hi, everybody. Yeah, thanks to the organizers and all the participants for being here and for having me. I, like you said, I'm kind of part of the broad U Chicago ecosystem at TTI Chicago. And so just a few words about where I'm coming from. So we are a computer science graduate institute. So we offer PhD degrees and we have tenure track faculty, but we're only a graduate institute. And we tend to focus on certain areas of computer science, in particular theoretical computer science, machine learning, various artificial intelligence areas. And so coming from that angle, what excites me here is that this ecosystem really includes so many labs and affiliates with open and transparent communication. And there's so many opportunities to interact and collaborate with top-notch people in many areas. So if you are an AI person or a stats person and you're wondering, hey, I think I might have an interesting connection between what I'm doing and what's going on in physics or social science or biology, you don't have to go far to find people to talk to. And often many people who are excited to talk to you about these connections, start up a collaboration, propose a grant together, and so on. And one thing that's special, I think I'm repeating a lot of what Mike and Catherine have said, but one thing that's special about the current moment here is the huge focus on expanding everything that relates to data science and making new connections between disciplines. So there's an opportunity right now to have a big impact if you have big ideas about interdisciplinary connections. And so that's one thing I find very exciting here right now.
Thanks, Karen. Last, of course, but not least, is Dan. I'd love to hear your thoughts. Dan has, this panelist, including myself, have by far the longest tenure here at the University of Chicago and has seen the change and growth that's been going on far back before I've arrived at many of these panelists. And I'd love to see how that's shaped your vision and future of data science here.
Okay, and good morning, everybody, and thank you for being here. So maybe one aspect I'll address first, it's the aspect of interdisciplinary research, right? So we know that all universities talk about interdisciplinary research, and it's clearly that's one of the modern aspects of university today is interdisciplinary research. But just to show you how serious we are about interdisciplinary research, I'll tell you a bit about my department, which is statistics, the department I chair, right? So in our department, we have I think the most diverse sets of research interests I've seen in a statistics department. So we have, the classical probability, mathematical statistics, high-dimensional statistical inference, machine learning. That's common in most of the statistics department. But we also have applied mathematics with everything it includes in our department. But I think the most important part is how serious we are about science and applications, right? We have people who do statistical genetics like myself. There are 4 statistical geneticists in my department. We have a faculty who is joined with ecology and evolution and does research about the development of Drosophila. We have 2 computational neuroscientists in the department. We have people interested in financial mathematics. We have people who work at the intersection of climate and environment. So, and I'm sure I'm missing, in my list. But this shows exactly on how the spirit of interdisciplinary, research has lived at this university for many years. In fact, one of the reasons I, decided to be a faculty at this university was the spirit of interdisciplinary research that allowed me to basically do applied genetics research in a statistics department, which was not very common 20 years ago when I joined the department.
Thanks so much, Dan. Yeah, I have to say, what Dan says and what this whole panel has really echoed around multidisciplinarity. I think it has been hard to reward at other universities, and it's built into the foundations of the way University of Chicago works in terms of its cross-division collaboration. And it's really exciting to see the impact that that's making. My next question, I think maybe the end of what I'd say maybe wheelhouse questions, is really around research. I think that everyone that's come to this panel as a rising star has very exciting research programs. And I think and they probably have their own view of where their programs are going. And I think it would be really exciting to hear from our panelists in your disciplines or your areas of focus. Where are those future data science directions that you see being developed? What are some of the exciting open questions that people are tackling right now? And you could think 1 year out, 5 years out, whatever horizon. And in this case, I'll let people volunteer in order as they'd like.
Well, from a policy perspective, we are just beginning to scratch the surface of what we can do with the amazing new data sets that are coming online. And this is a more of a 30,000 foot comment, and I'll let others drill down as is interesting. Crossing silos is crucial for addressing the public policy issues that people in lots of different areas are interested in. You know, people have multifaceted lives and multifaceted issues that we want to address. Homelessness is not just about physical housing. It's about mental health and substance abuse and poverty. And health is not just about health care, but it's about investment in early childhood development, and it's about access to food, and it's about criminal justice. You know, all of these things are intertwined from a policy perspective, but the data that we now have available, if we can merge data sets across silos, we can do a much more sophisticated job of predicting populations that are at the greatest risk and targeting resources to those populations where they're going to do the most good. So it's both about prediction and about estimation, and the sophistication we can bring to that is dramatically enhanced if you can get data from healthcare and marry it up with data from child protective services and marry it up with data from the criminal justice system. We are now much better able to do that, both because of the data that's available, but also because of more sophisticated merging algorithms and innovation in how people collect and harmonize these data sets. So I think that's going to be a huge boon for public policy, and we have barely scratched the surface of that.
Thanks, Kate.
Okay, maybe I'll go next. So I think in statistical genetics, the main challenge is preventive and personalized medicine, right? So traditionally, medicine was done with limited data. You go to a physician, and a physician has access to, tiny bits of information from your clinical record, and maybe, some imaging, but sort of limited information. But you can envision that in 5 years, this will be done with a huge amount of data, right? So it will be done with genetics and genomics data. And by these are all data sets that have tens of thousands to millions of features, right? It will be done with the data that comes from clinical records of the patient, but also sort of, maybe of the extended family. And it will be done with data that comes from wearable devices, whatever that is, in a generalized way. And the question is, how do you put all of this together in an accurate way, but also in a fair way? There are a lot of important issues around privacy, ethics, fair representations, and this is related to what Catherine was saying before. And, how do you do all of this? This is, in fact, a big data science problem.
Absolutely.
I can jump in. So I'm coming from the angle of somebody who's working in artificial intelligence, and specifically in language and speech. And one of the things that's been happening in all of the areas of artificial intelligence in the last couple of years, maybe the last 3 years, is the explosive growth of pre-trained representations or features, and in the use of unlabeled or weakly labeled data to learn those features. This is not a completely new idea, but it really started sort of working in natural language processing about 3 years ago. And I'm sure many people in the audience are familiar with things like Elmo and BERT and GPT. You might have seen them in the media, if not in your own research, for learning representations of language from large amounts of unlabeled text. And in other areas of AI, like speech or computer vision, this is also starting to gain steam and starting to enable real improvements in performance on tasks that we care about. And all of these ideas in this recent work rely on having access to very large amounts of data. And these might be unlabeled or they might be weakly labeled, but they're very large amounts of data. So one thing that I'm looking forward to in the near future is methods that can do more with less data. Mm-hmm. Yes, data science, but less data. So even less unlabeled data. So just to give an example for those who maybe aren't, that familiar with the recent news, the most recent GPT-3 model for English text was trained on hundreds of billions of text tokens and has 175 billion parameters. And this is not something that can be replicated for most other data domains. So as somebody who works in speech and language, I spend a lot of time thinking, what should we do about all of the languages and speakers for which we don't have much data at all? What should we do about unwritten languages, sign languages, various dialects, non-native speakers, speakers with various speech or language aphasias or dysarthrias, and so on and so on. And this is something that comes up, that I think about it in terms of speech and language and communication, but this comes up in all areas of AI, where there just isn't enough data to do all of these amazing things that we now know we can do with lots of data. And this is, again, something that researchers have been thinking about over the years, and there has been a lot of progress, but it's a general problem that we don't have a general solution for. So there are many other exciting open problems, but this is one big topic that I think I'll leave it there for now.
Okay, I'm really excited that you're thinking about doing things with less data and these sort of self-supervised methods. I think that's a really exciting direction to be thinking about. When we started looking at data science at the University of Chicago several years ago, more than several years ago now, I guess, one of the thoughts that we had was that if we were really going to create a new field of data science, that there had ought to be research problems that weren't being adequately addressed in existing domains and disciplines. And so we had a group of faculty from around the campus, and we brainstormed a bunch of research questions that we felt fit into that category, that they were either questions that weren't being adequately addressed currently because they weren't squarely in an existing field, or maybe they were questions that weren't even being asked yet because they fell between the cracks of existing fields. And we came up with a list of about a dozen of those, which I think are all really fascinating. The one that really caught my attention and I thought was particularly interesting in the context of the University of Chicago was the question of economic models of data. So, there's a lot, if you look in the popular press, there's a lot of discussion about data. The value of data is data being the new oil, or there was a company that was, one of their slogans was that data is the new bacon. There's been lots of analogies of data as a commodity and the fact that data has some inherent value that you can build markets around. But if you actually think about it, data doesn't behave like oil or bacon or any other traditional commodity. And we really don't understand some, just very basic questions about how to assign value to data and whether it's monetary value or some other metric, and how that changes over time, and how you would build a marketplace, an effective marketplace for data. And obviously, this is a huge opportunity from a business perspective, and it's also a huge question for allowing data to be used to its fullest extent for the types of applications that everyone's been talking about so far, in this panel and elsewhere. And, there's obvious things about data that are, if not unique, at least rare, like the fact that it can be, copied, in an unlimited, to an unlimited degree and so on. But I think there's a real subtlety that a lot of people have missed so far in the discussions I see about data markets and data value. And that is that there's an inherent connection between technology and the value of data. And so what I mean by that is, for a given data set, there are certain things you can do with it today. But as like Kate was talking about, if you can take that data and combine it with another data set, all of a sudden you can start answering questions and seeing things that you couldn't see before.
And so, how does the fact that you might be able to combine some existing data set with other data sets that are out there, how does that change the value of those data sets? Or, alternatively, it may be that when you combine a data set with something else, you actually violate somebody's privacy, which actually then increases risk, and it means you can't use that anymore. So that actually decreases the value of the data. As data integration technology gets better, that's going to have an impact on the value of data. Likewise, as privacy technology gets better, if you can come up with a way to allow people to exploit a data set that has private information in it, but in a way that doesn't leak that private information, all of a sudden you can extract value out of that data that you couldn't have extracted if that technical advance hadn't been made. And so I think there's a very, very fast feedback loop between the development of data management and data science technology and the marketplaces and the applications and the things that you can build on top of that data. And so this interaction of economics and business and policy and technology, I think, is unique to data science as a field, and something I think is really worthy of a lot of research.
And just to riff on something that Mike was just saying, I think that's such an important point because it implies that we're not optimally investing in the development of data sets right now because they're, fall back on economics terminology, there's an externality, usually positive, but sometimes negative, as Mike highlighted, to every new data set that you develop and every new tool that you develop. And if people are investing in data based on today's technology and based on only the private return, we're going to have too little investment. Whereas if there are spillover effects to other entities, or if there's spillover effects to technological advancement that make every datum that's collected more valuable, there ought to be some policy levers or some economic framework to properly incentivize that investment. And that could unlock a lot of value that's being left on the table right now.
Thank you. Yeah, no, I think this discussion is just reminding of, there isn't a field I think that hasn't been touched upon through this discussion yet. It also, though, I do want to circle back with sort of my last open question to the panel before we get into some more specifics, and we've already received some questions from our group here, is really one around ethics and bias, right? So there's now, it's very clear there's a widespread realization in data science revolution that the impacts can be positive, they can be severely negative. How are each of you thinking, in specifics around these issues in ethics and bias? And in some respects, we need to think about it in our research, but we also need to think about it in our training. What are we doing with our students here, or what are we planning to do to ensure, as we define this field, we're setting out the right expectations from the outset on how to question the work and how do we question the data in the appropriate way. And I'll leave that out there for now and take your responses.
Well, I could start since I'm unmuted, but we have obviously too polite a panel here. We gotta drink some more coffee. But I'll just mention one aspect of that. I mean, as you point out, it's important as we're defining this field of data science that an inherent and key part of that field is, the ethical and fairness and accountability questions, that come up when you're making decisions based on data and when you're collecting data and all these other things. And so, it is an incredibly important area. I'll just mention one thing that we're doing in the current data science program that we're running at UChicago, the data science minor for undergrads. We created a new data ethics class that is a required class for people that are doing a minor and eventually a major in data science at UChicago. And the thing that we tried to do when we created that class was to make it more of a technical class, or I won't say more of a technical class, but to make sure, kind of getting back to the points I was making earlier, that when we're thinking about these fundamental questions about data and how to use it, we're also doing that in a technically sophisticated way. And so this is an ethics class or a fairness in data class that requires a substantial amount of programming. And what the students do in this class is they implement different techniques for privacy preservation and for question answering and things like this. And they experiment with what the limitations of the technology are. And so we try to give the students a hands-on understanding of what the goals are in terms of fairness and accountability and transparency, but also give them a chance to figure out what's involved with actually trying to build that in a working system, which is just an interesting angle on that question.
And we have a lot of examples of algorithms applied to public policy problems like the granting of bail or parole choices in the criminal justice system, or targeting healthcare resources in health insurance design and health services delivery, where the tools are dazzling and obscure, which is a problem because I think people have those who are less informed than the people participating in this meeting have this idea that, computers can't be biased, it's just the numbers. But of course, we know that algorithms that are drawing on data generated by a biased system can just continue to bake in those same biases. And it's not as transparent as a simple linear regression where you can see what the covariates are might be. Of course, people are also biased in non-transparent ways, and individuals making decisions have these biased algorithms in their head that we also can't see. And so there's an opportunity to interrogate the algorithm along the lines that Mike was talking about in a way that is more challenging than interrogating the person making the decision. And so we have a chance to both uncover systemic biases that are baked in and think about how that means we want to adjust our protocols. And I think there's an opportunity. There are great examples, both from healthcare and from criminal justice, where you can undo some of the biases in the pre-existing system while improving the outcomes that you care about. That it's not always, it gets you out of what might otherwise seem to be a trade-off where you have to choose between two things. You can accomplish two good things, reducing bias and improving outcomes, if you're thinking about it in a sophisticated way. And again, it comes back to some of the strengths that we can bring together here at the University of Chicago, which is the algorithmic sophistication with the analytical underpinnings to really get under the hood.
Agreed. Exciting. All right, so I will, unless I know Dan spoke to this a little bit on medicine. Actually, Karen, I do want to provide your thoughts on this. Language models also have some, I think there's some very well understood risks even with the new language models and their potential impacts. I'd love to hear your thoughts a bit on that.
Sure. Ethics is a very large term. Bias is a somewhat smaller term, but still a very large term that has lots of different flavors. So one that I think we haven't talked about yet is the bias in terms of whether technology is reaching all populations. Mm-hmm. And that relates to one of the topics I mentioned before about being able to do more with less data. So populations for which we have less data, how can we make sure the technology, they reap the benefits of all of this technology, just like better represented populations? That's one. Another one that I think was just mentioned a minute ago is about how the technology might be just working less well on certain populations in ways that can be extremely damaging, like credit score estimates or criminal recidivism estimates that are biased against certain segments of the population. And this can also come up in language models, as you mentioned, that are trained on data that we know very little about, and I'm not sure the researchers who developed it know very much about. And there's a real question of how much responsibility the research community has for addressing this issue versus the entire pipeline of how things go from research into popular use. And often this comes about, like Mike and Catherine were saying, because tools are being used in a different way than they were intended, or simply used incorrectly. Where if you went back to the original researcher that developed the tool, they'd be like, well, of course it wouldn't work properly in this setting. What are you thinking using this tool in this way? So the first responsibility that I think is sometimes ignored is just to communicate very clearly what our tools can and cannot do, avoid the temptation to overhype, or even to allow the media to overhype our research results to the extent that we can. And there's also research questions that directly address how to avoid or mitigate or at least expose bias. There's both theoretical questions about what kinds of bias can be mitigated and how. So this is an area of machine learning. Also practical sort of research hygiene questions about keeping track of and disclosing sources of data and metadata. As a research area, this isn't a research area I'm personally working on, so I'm giving a bit of a side view from it, but I'm an onlooker who has a very close view of some of this work. One thing I want to add is this is a topic where maybe academia has a little bit of an edge over industrial research labs, in that industry is eventually accountable, as they ought to be, to their market and their shareholders and so on. And so they have conflicts of interest that academics can often avoid. And of course, we sometimes have our own conflicts of interest, but I think this is maybe an area where it's maybe easier for academia to really lead. So I don't have answers, but those are some thoughts on that topic.
I think that positions us well. We have two great questions around ethics and social impact from the audience now. So what I'd like to do, excuse me, is I'd like to start with one of our rising, excuse me, Abby Smith, really has a question around, okay, there's a problem, or maybe there's solutions. Is there ethical partnerships? Is there social impact partnerships that the university is looking at? And really, Abby, though, I want to allow you to sort of riff on that question. So by all means, please unmute if she can. Okay, there she is.
Hi. Yeah, I had actually asked this question, or I was trying to ask this question to Becca because she talked a lot about collaborations within academia. And I was just curious if you've had any data science partnerships with nonprofit partners and what those look like and some of the challenges with that, or if you know of any people who have managed to do that really well. Just speak on that.
I might jump in by starting with just a quick overview of the urban labs at the University of Chicago. They sit at the Harris School, but there's the crime lab, the education lab, the health lab, the poverty lab, and the energy and environment lab. And they explicitly work with local partners, often government, but sometimes nonprofits, to embed data analytics within an innovative policy that's being deployed, to assess more quickly what's working and what's not working and speed up the innovation cycle. And a lot of those experiments involve collection of new data on the ground in real time, and the researchers are often embedded with the partners. There's a great example from the crime lab trying to get better forecasting of when mental health services might be necessary for responding correctly to a call and collecting the data in advance of calls coming in partnership with the police department to better respond proactively to calls that come in, or targeting, resources to areas to prevent violence rather than react to it, or the Poverty Lab working with the city of Chicago to understand where housing vouchers were going to be the most important in preventing evictions that would lead to homelessness in the middle of the COVID health and economic crises. Those require more sophisticated data analytics than the partners can usually provide on their own because of limited bandwidth, limited resources and expertise, but also then lets the researchers see firsthand what policies are actually being experimented with and evaluate them in a much more rigorous way. And so it has multiple advantages, that model of partnership, and it's the one that all of the labs draw on.
Great.
And David, you have worked a lot in building this type of partnerships. So I'm turning the question to you now. Maybe you can tell me about your experience.
I was gonna. Okay, so I'll just briefly mention I'm really excited that this was asked, because really from the onset, this is going to have to be a meaningful part of the data science we're working here, is to actually get out of academia and get right to where the communities of need are. So right off the bat, we've actually launched a clinic model of research and project-oriented partnerships with a lot of social impact. Right now, this is actually being led and funded by the 11th Hour Project. And there's a number of groups we're bringing together, and students that have actually already started solving and working on these really hard problems. And we actually would be delighted to integrate everyone in the community into these opportunities. And they're just at their beginning now. Okay, I do realize, though, that we've got 4 minutes left and now a whole bunch of questions. So maybe I'm just going to ask Chris Grazul, would you like to ask your question to the panel? If I said that right? And
yeah, sure. So this is a question that might not be too surprising to some people, but basically I'm trying to understand, given the data that are out there that we can use, what is our role as data scientists, or what is the data science community's role in informing the development of policy, specifically legislative or regulatory, sort of formal policy, to address concerns around the ethics of potential bias or privacy or other issues. Because I think that one thing that might be happening, or at least is happening in projects I'm working on now, is that new data sources are coming online all the time, and they're being used in ways that are fascinating, but there's questions about, should we actually be using these data? And there's actually very little protection around certain forms of data that you would think would.
All right. No one's jumping. I was hoping our policy dean would jump in on that one. But I mean, obviously, academics and data scientists should be playing a huge role in addressing those questions. I mean, I don't think anyone right now has all the answers, of course. Hopefully we're moving into an administration that is going to be more open to listening to voices from the research community. And in the past, we've had the ability to have quite a bit of impact on questions like this. I'll just mention, though, it's hard because, getting back to this issue of the value of data, and how do you get the most out of the data that you've been able to collect, and maybe spent a lot of public money collecting that data. Sometimes you don't know, when you collect a data set, what else it might be useful for learning about. So, for example, at UChicago, Michael Greenstone and his group has been doing a lot of fascinating work on understanding, the health impacts and the financial impacts of air pollution, using data sets that weren't necessarily collected to answer those kinds of questions. And, there's real value coming out of that. And so I think as we, as data scientists, think about these types of questions, we need to be open to the idea that we don't want to restrict things so much that we're missing out on important societal benefits that we could get.
Yeah, and to part of the reason that I didn't jump in is because there's no easy answer in the 1 minute that we have remaining. What it means for data to be de-identified is a moving target. Like, we used to just take people's name and address and social security number off and think we were good. And of course, that is not de-identified data in the modern world, where there's so many data elements, and any combination of them uniquely identifies an individual. We have to think more carefully about what we are promising people when we tell them that their data is going to be de-identified. And we have to think about, when things are sufficiently anonymized or aggregated that you don't have to get individual permission, because so much of the value we've been talking about in massive data sets in combination with other data sets is not practically individually consentable. So you have to think about how we can use the data in a way that's responsible based on the conditions under which people have given the world access to these data and being really transparent about that. And I don't think we have the right answer about how to thread the needle. And it's particularly salient in healthcare, where, of course, people need to provide individual level data to get individual treatment. You can't expect, people need to feel completely confident in giving information to their healthcare providers that nothing's going to happen to that data that they're not comfortable with, or we won't be able to treat patients. But then there's this enormous value in the aggregation of all of that information to develop new medicines and new treatments that might not benefit that individual patient, but would benefit society. And how do we set up a framework where people as individuals feel comfortable with that, and that we're not doing anything that is surprising or upsetting with their information, but we're not leaving on the table the opportunity to cure cancer down the road because we have all of this data on people who are getting treated for cancer. So I wish I had a better answer, but I very much agree with Michael Franklin's point that we need policymakers to be developing an environment in which we can make rational decisions about this and thread the needle.
Thank you so much. And with that, I can think of no better sort of way to end a Future of Data Science panel with a very hard fundamental question answered by more questions. And if that isn't a preview for the types of ways we're thinking hard about things around the future of data science here, and if that's attractive, think about coming to join us. I'm also just going to practice and thank the panel silently with my clapping emoji. And with that, I'm going to hand this back to Julia.
Thank you, David. Thank you for the panel. That was fascinating. For folks who are joining on the live stream, please come back at 1:15. We'll have another public panel that's going to be on interdisciplinary data scientists, on interdisciplinary data science research. So we'll have folks from sociology, ecology and evolution, human-computer interactions, talking about how they work together, how they work with different groups. So that'll be a great panel as well. For folks on Zoom and Rising Stars specifically, we're going to take just about a 4-minute break, and we'll reconvene at 12:05 or so for our first spotlight session. So thanks, everyone. Talk to you in 3 minutes.